All right, now I want to go into another example of an object. We looked at the complex object. We've talked about some things about that object. Let's look at a different object that's a little more sophisticated. A string object. I'll call it cstr. That'll be the identifier, the name, but just I'll call it C string in the video so that you know what I'm referring to. So we're going to write a class that manages a raw character array that holds a string, and we're going to call this C string. And there are three constructors that we're going to add to this class. One, a default that creates a null string. One that makes a blank string of a given length, and another that initializes our object from a literal character string. We'll also add another member function that allows us to access or modify elements of the string that are within bounds. And out of bounds accesses will just be silently ignored. Okay, so here's some example uses of our object once we have it fully made. And you know what, anytime I'm designing an object, I often do this. I write out the code for how I want to use it before I write the internal code, so that I really think about what I want the interface to be like. And so here, like I can make my new string C and I can set it equal to a literal character string. That's the third constructor I described. And then if I want to, I can use that last member function I talked about. It would allow me to modify elements of the string. And I can say c.getZero equals capital H, and that'll replace that lowercase h with a capital H. And then if I said c.get100, well, this 100 is out of bounds of the array, so when I try to set it to X, nothing will happen. I won't have a segmentation fault or anything weird like that or memory access error. It's just going to get silently ignored. Okay, and then c.print will print the string out. And it'll print hello with a capital H because I changed that first element from a lowercase h to a capital H. Okay, so this is kind of how what I want my object to provide. Okay, so to start with, I don't want to forget my principles of abstraction and encapsulation. And so I'm going to make my members private, and I'll have a character array. Actually, this will be a pointer to an array that I'll allocate with new, right? So the star here is the way I indicate that I'm holding a pointer to something. And then the size field will indicate how big I make this array in memory. And just a reminder, when you're creating your own objects and you start building them from scratch, remember you have to have a semicolon at the end, just like a struct declaration. Okay, and now I want a default constructor that just sets my array to be null and the size to be 0. And so the way I do that is in C++, the recommended way of setting something to a null pointer is this special, let's just call it a special name called null pointer, and it'll set array to be 0, right? But it's basically, it has a special type that allows it to be recognized as the special null pointer value. And then we initialize size to 0. Now this is a notation I haven't showed you much before, but when we write a constructor and when we are only like initializing the fields to constants, we can use this alternative notation where we, after the constructor name and parentheses, we just put colon, and then we list the fields in a comma separated list, and then in parentheses, we place the values we want it to have. And then the open brace, close brace, because we don't have anything else we need to do, there's nothing in between them. It's just a function that doesn't do anything. Okay, so this is just an alternative notation for initializing fields. You can use this in any constructor anywhere, but it's especially convenient when all you need to do is initialize a few fields. Okay, I also want a constructor that will set my C string to be a long blank string. And so the way I can do that is by passing in an integer and to my constructor, And then what I'll do is I'll use new to allocate a character array that's size plus 1. And the reason I need to add 1 is to make space for the null character. And then my for loop here will loop over that array and initialize every position in the array to a blank space. And then set the last value in the array to 0, or in other words, a null character. And that provides my sentinel null character that terminates the string. And then the one other constructor I wanted was to be able to initialize it from a literal. And here I'm going to cut a couple of corners just to be a little quicker. I use the string length function from the string.h library. Yeah, it's a C function, but I still have it here available in C++. And so string length will calculate how long this array is. And so I set my size variable equal to the length of this literal. And then strdup, string dupe or string duplicate, will make a copy on the heap of this string, and then I'll return a pointer, and I'll save that in an array. And so this very quickly makes a copy of this literal and puts it in my object for me. Okay, so that takes care of my constructors. And this will give me those constructors that I wanted. Now, I also want a member function that'll let me access the array and modify elements, right? I showed you that get call that I passed an index to that will let me change parts of the array. So the way we do that is that we use the reference operator to return a reference to a location inside the array. And this allows us to either read or write to the array. And that looks something like this. So we have a function called get, it takes an index, and then we're going to return the array at this index. Okay, but because my return value is a character reference, then what this really means when I say return array index, it means return a reference to this location. And since I'm returning a reference, I can use that reference to either access that position in the array and read it, or I can use that reference to modify that position in the array, because that reference is identical to, it has the same meaning. It's an alias for that position in the array. So it's very powerful. And this gives me the functionality that I want, right? And so then this is how it looks. So that's the basic functionality I need. But the one other thing I wanted, I almost forgot, is I need to handle out of bounds accesses. So if somebody gives me an index that's less than 0 or greater than the size of the array, then I want to ignore that and not modify my array. And so I do a little trick here. I put an extra field in my object that's called dummy. And you'll note this is private and this is hidden from the user. So any user of this object, they don't know this is what's happening. So I just make an extra little dummy field. And then if the index is out of range, I return a reference to the dummy field rather than somewhere in my array. And then they can just write to this dummy location all they want if they're giving me a bad index. They should know better and not give me an index outside the bounds of the array. But if the bound is legal, then I return a reference to the actual location, the legal location in the array they wanted. Okay, and this fulfills, the requirements I wanted from this function. Okay, and now if you run this code, it's going to work. And when you call c.get0, this call to get actually returns a reference. And that reference then is modified, right? The reference to that location in the array is modified to hold a capital H. This call to get with 100 is out of the bounds of the array. And so it gets ignored and actually return a reference to dummy. And dummy gets modified to X. But, when I print out the array, dummy's never printed. So, the end user would never notice that. And instead, this print statement is just going to print out the copy we made of hello. Now this C equals hello, this may not be obvious, but this is using that constructor that we wrote. There's this nice special rule that if you have a constructor that takes a single argument, what you can do is when you construct object C, you can say C equals something of that type of a single argument. and it will call the correct constructor that takes that argument and use it to initialize the object. Now, this does lead to kind of the weird implication that I could say C string C equals 5, and that would make a string that's of length 5 with 5 spaces inside of it, a blank string of length 5. And that would also work. But here we just set it equal to hello, and that means I'm going to call my third constructor, copy this hello string in, and then these other operations will proceed as we described on this object. Okay, so in summary, this C string class encapsulates a C string in a convenient interface. We have 3 constructors that give us several simple ways of making a C string object. The get method returns a reference to make modifying the string contents easier. Because it returns a reference, I can either read or write to the array. And the extra checks in get to avoid an out of bounds access are totally hidden. And if it is out of bounds, we just return a reference to dummy, and that those out of bounds accesses get taken care of, in a kind of neat way. Now, just to pause, we could ask the question: is it really good for us to hide those out of bounds accesses? I mean, if a programmer is trying to access our array using an illegal bound, then they're probably doing something wrong. They don't realize that they're accessing outside the bounds of the array. And it's true. It might be that if it's an out of bounds access, we want to report that behavior rather than just silently ignore it. But anyway, this is a made up object for me to illustrate a few ideas and to promote this kind of thinking. So I'll let you guys decide whether it's a good idea or not. I know what I think, but hopefully you learned something from the design of the class either way.